Okay, here is the video for Math 3 3.6 task, a solidified task. It's called Seeing Structure. What's going to happen is I'm going to show you guys each equation. I'm going to show you the pause button and say, hey, work on that, tell me all the features, graph it, and identify the end behavior. And then I'll tell you pause, and then I'll show you the answer and talk about some features real quick. Okay? If you read this statement up here, modify Claire's statement with what we worked in on 3.5. Remember, if we have multiple zeros at one point, they kind of kiss the x-axis with not necessarily crossing or going over, depending on the degree. Okay? So here is equation number 2 right there. Go ahead and pause and figure out the features and graph it. Go. All right, come back. Let's see if I can show you the answer without showing you everything. The zeros are 0, 2, and 4. I multiplied it all the way out to find it's a cubic with a negative coefficient. So there's the end behavior. Plot the zeros. I actually, on all these functions, plugged in some extra points into the function. Just plug it into factored form, so it's really easy to figure out. Find out how high or low the relative minimums go. And that's how you get that answer right there. Okay, and you can stop the video or get ready. Here's the answer for question number 3 after you guys pause and try it for about 4 or 5 minutes. Okay, here's number 3. Let's see, I factored this into x plus 2 quantity squared, so I'm going to have a multiplicity 2, 0 at negative 2 right there. See how it kisses the x-axis? This is a cubic with a positive leading coefficient, so it's down up. I figured out these points right here at f at negative 1 and negative 3, and it helped me get the correct shape. Okay, let's go on to number 4. Oh, I give it away. I helped factor it for you. Go ahead and work on number 4. Okay, let's see here. Stop there. It is a cubic, again, positive leading coefficient, so it looks like this. I kind of garbled up the kissing the x-axis at 0. It kisses because 0 is the multiplicity to 0, right there. And I figured out how far down it went at f of 1/2 and f at negative 1. Didn't really help me get a better shape of the curve. Okay, let's look at number 5. Ooh, this is a good one. Okay, this is a difference of 2 squares you can kind of factor twice. So you can factor this x squared plus 4 into x squared minus 4, and then I can factor that difference of 2 squares again into x plus 2, x minus 2. So I know my zeros are at plus and minus 2 from this. How does this factor? Do you remember how to factor using imaginary roots? Well, it becomes x plus 2i and x minus 2i. We'll get back to that later. So our intercepts are there. Here's the graph. Kind of flattens out down here at negative 16. And I plugged in several points to try to figure out the shape. And I said, hey, what happens down here? Does it get flat? And yeah, I graphed it on Desmos, and it confirms this is about the right shape. Let's move on to number 6. This is becoming a lengthy video. Factor that, factor it again. There we've got zeros there. We can plot, and we figure out it goes down here to about this point, plugging in exact values. Okay? So the answer to question number 7 and 8, how do we graph a polynomial that's not in factored form? Well, we factor it or use Desmos. And if we know one root of a cubic function, can we find the others? Yes, we're going to do that by factoring or using synthetic division. You're like, wait, what? Synthetic division? It's kind of like long division. We're going to learn that next lesson.